What's up YouTube? This is the sixth long video on Kyle's global weather. Today we're going to be talking about why so few people live in certain areas of Washington state. And it's going to be a long video today. I've got around a 25 slideshow prepared for you guys, and it's just going to take a while to go through it all. I'm really upset I didn't get a video out last week. I'm going to plan to make that up at some point. There'll be a week where I post two long videos. I was just really busy, honestly, and then the days went by and I just got too lazy. So that's on me. But I'll fix it in the future. Anyways, let's get right into the video. Why does almost nobody live in northwestern Washington? That's the section of Washington state we're going to focus on today. So let's just make this really broad. Why do civilizations settle in certain areas? Well, I can think of four big criteria at the moment. Obviously, there's so many of them. One is water, another is because it's flat, and then a third is trees and animals, and a fourth is just the overall climate. And you might think that the areas of Washington have the first three of these, but I'm about to tell you why that's just not the case at all. Here's a population density map of the United States. As you can see, the red dots indicate that there's more people in certain areas. Almost every little bit of the American coastline is completely dotted with red areas. If you look a little bit more carefully, you can see some areas just don't have as many red dots as others, but there's a little outlier up in the northwestern corner by Washington. There's just a huge area with no one there. So that's one, that's coastline. That's water. And then just another source that corroborates, 2/3 of America lives within the 100-mile zone, and we're talking about an area that's right on the coast, well within the 100-mile boundary, and most Americans would live in that area, but just not in this particular area. And then it's also about the flatlands. So we want to look at, does the land have low elevation, and can we successfully navigate through it and plant crops there and really just branch the civilization there? That's what people have thought over history. So apparently that's not the case with northwestern Washington. As you can see, the elevation is pretty low in this area right here. But just people don't want to live there. As you can see, the population density map, it's near zero for those areas. It's around maybe 5 people per unit of land. But areas like Seattle and all these coastal areas, more inlands, see so many more people. We're just going to explain the discrepancy between those and why people live there, but absolutely no one lives there. No one lives here in the very western areas. Go looking up the biggest populations of this area is places like Ocean City. I have no idea where that is, but only 100 or 300 people in each town. So it's really just no one there. And you would think it's the west coast of the United States. There's got to be people there. The answer is no. So where is everyone? Let's talk about it. That's why I'm here. One of the main things that separates the Washington area apart is because of its stronger western winds. We call them westerlies. And there's 4 big reasons why these happen. Here is one of the main ones. It's the water currents. We talked about this in the last video, actually, and it affects areas like San Francisco and areas all the way down the west coast and into Canada and into Mexico as well. But these are just one of the broader regions. You can see there's a gyre that stretches all the way across the Pacific Ocean, and that's what California and western states are affected by. And more specifically, you have the California current that supplies cooler water towards the California area, and you have the North Pacific current that supplies more warm water. The second is the topological areas. The area we're going to be focusing on today is west and southwest of the Olympic Mountains, and it's a huge area of the state. Relatively, it's it could be like most of the flatlands around there, maybe like 50% of the flatlands is around that area, and there's just no one there. And really the wind is just going to flow all around the mountains, and some of it's going to go up the mountains, but a lot of it is going to be squeezed through these mountain ranges here, and that's what's going to influence the weather to a high degree. Another is the jet stream. The jet stream on average positions itself right along Washington state for like a good amount of the year, and if it's not there, it's really just north or south of it. And when the jet stream is on your state, that really influences the weather, and it can cause really drastic conditions. And another one is something called the land-sea breeze circulation. It's a phenomenon that might take a minute to explain. So basically during the day you have cooler waters and then the land is warmer. Now this is a discrepancy. You're going to have the air trying to move from that higher pressure area to that lower pressure area. Cooler waters is going to influence the air right above it to be a little bit cooler, and that cooler air just has lower pressure because it's lower temperature right there. And the wind is going to end up moving, but when that happens, the air that goes onto the land warms up. What happens when air warms up? It rises. It rises because it's lower pressure in this scenario. The warm air is going to go into almost a cyclical pattern. But at night, this is the reverse. You might ask, how can it possibly be the reverse? You're not switching the land and sea. Well, it's because of the specific heat capacities, and it's basically like a surface's volatility to changes in temperature. To keep it simple, water is very resistant to temperature changes. It rarely does. But in lands, it's almost like 30 times more. It could be up to 30 times more susceptible to changes in temperature. So that's why you get these differences. And you'll see this is a very prominent factor in the northwestern Washington area. So I mentioned all these different phenomena, but really, where are they coming from? The jet stream is all the way up into the mid to upper portions of the troposphere. It could be anywhere from about 6 to 10 kilometers up, just right above you. So that's where the dominant forces are going to be coming from, and just overall big circulation patterns. But then you got other kinds of winds, like the topology, that's really influencing winds around a kilometer or two above the head. But then currents and circulation is really just a hyper-local factor. It could have minor influences in temperature, right, and weather overall, and that's why we call it a microclimate. But it's not going to be the main event in terms of the region. You're really looking at the topology and the jet stream. Okay, so there's wind. Is that really the end of the story? It seems like I just listed everything. Well, there's lots of side effects to wind, and we're going to go through a lot of them. So wind is going to end up picking up moisture. Wind is one of the catalysts to evaporation. There's many different factors, but basically when there's wind there, when there's faster moving air, the water particles are going to want to become airborne, right? And there's just a greater chance that there's enough kinetic energy that's redistributed to the water particles that they can ascend to their water vapor form. When this happens, the air is going to carry that moist air over lands, and then the process is going to essentially reset, and then more moist air is going to be flowed through because the original air right over the water becomes less moist. So it's almost an endless cycle, and then the land just becomes more moist as time goes on by a small degree. So that's basically the main thing in terms of just making the air more moist because of these westerly winds. But really, there's so many different factors that wind could have a play in. We talked about upwelling in our previous video, and it's basically different layers and elevations of the ocean moving up and moving down. There's salinity changes, so you might have very delicate ecosystems, right, in very certain areas, and they might be in close proximity to each other. And when this happens, you could have different bodies of water interacting with each other. There's also just temperature changes, right? If you have the different air masses interacting with each other, that's always a catalyst for something to occur. And especially with the water and the lush forest, a lot of minor things occur, and just gas exchanges, really. Winds promotes the absorption of CO2 into the water, so that's pretty unrelated to average day weather, but that's something that's related to the global climate. So here's our main event, and there's many reasons why this is just so prominent in this area. I mean, first of all, we just have these westerly winds that we went over. We explained all the different reasons that they occur. And what happens is you have these big Mount Olympus mountains as we go back here. this is the area we're going to be focusing on in our video. This is where the phenomena occurs so often. We're about to explain it. And there's also just more moist air because of the factors I described. And it's also, there's moist air because of factors I'm going to explain later. But anyway, let's just get into it. So when more moist air happens in this region, it is pushed east by the westerly winds. The air essentially has nowhere to go, so it just rises up the mountain. What happens though? There's got to be a change. We call this a change in the air. Convection. There's many kinds of convections, but we're just going to talk about temperature and moisture changes. The moist air is going to cool down, and there's a lot of opportunities for, condensation nuclei and particles to allow this precipitation to form if there's simply enough moisture there. We have not explained, precipitation forming in enough detail, but, if you just think about it logically, if you have a lot of moisture concentrated into a certain area and it's almost around cloud level, so just using your own knowledge, it's a catalyst for precipitation. The precipitation only stays on the moist side, but as you can see, this air, it may make it through over the mountain, but at that point all the precipitation and moisture will have already fallen, right? So once you get to the other side, it's going to be significantly less moist, and you're just not going to have that much moisture. It's going to be a lot drier on the other side, and that's what we have happen. We have these micro low pressure systems and rain bursts forming over this area, and they get stuck in place because of these mountains, and a lot of effects get exacerbated. In the higher levels of the atmosphere, there's also a lot of events that occur specific to this region almost. There's stuff that happens like vortical strengthening, which basically has to do with the air masses having rotational energy. And there's many different kinds of vorticity, but they really influence storms in profound ways. When you have these setups where you have storms going along the west coast, there's just so many dynamics in place. We'll talk about it in future videos, but basically the westerlies almost spin up the counterclockwise motion, and that itself is going to enhance the westerly winds. As you can visualize it, just going around in a circle, you have the westerlies blowing from the west. So it's almost like a feedback loop, and that's something that happens a lot. Convergence has to do with the air masses interacting with each other in the horizontal layer, and if there's a surplus of it, that can promote vertical flow, and when there's vertical flow, you have more complex dynamics and more complex storms. And steering of air masses. When you have strong low pressure systems, they influence all the bigger air masses surrounding it, which has a broader impact on not only the local region, but just almost like a continental impact. You really have just huge weather systems shaped by something that could really just occur near the Washington state. It could really expand. And that happens a lot of times. So let's really expand on why there's so much moisture, which allow phenomena like the rain shadow effect to occur in such strength. It's really the jet stream is one of the main things. It's just so profound. In certain circulation patterns, you're having to do with monthly times like PNA patterns, or yearly times like El Nino or La Nina, or even Arctic circulations. All of these things can affect the position of the jet stream over long periods of time, which can affect the real seasons of areas like Washington state. And you can see it really positions itself right over Washington state a lot of the time. It's very susceptible to changes in weather. You have phenomena like atmospheric rivers. I can go into that in more detail in a future video, but it's essentially a layer of the atmosphere that has so much moisture in such a small area. It could be maybe a few hundred miles wide, if that, and it just gets so concentrated and it spills over into certain areas repeatedly. You might have heard on the news that places like California had experienced these atmospheric rivers, and it leads to ongoing precipitation. And the thing is, with Washington, there's just so many mountains, especially on the western side of the state, that all this precipitation simply gets blocked. And you might ask, why is this not happening to Seattle? Well, at that point, a lot of the precipitation has already fallen, Pacific Ocean is extremely strong and it influences, all these other rivers. And at that point, a lot of the rain will have already fallen in the western areas. Seattle just doesn't get as much rain. It also just has to do with the climate. There's certain phenomena that occur on the Pacific Ocean coast that, promote certain kinds of climates from forming, to promote certain kinds of climates to form. When you have lush rainforests and like on a certain area, you'd probably rather not live there. That's not what Seattle is. It's slightly different. Okay. So let's look at other aspects that make the region unique. A lot of this is stuff that I've already said, but the currents provide contrasting temperatures in water. And then Washington State is really the only state that interacts with both of these contrasting temperatures. So when you have warm water and then cool water, you have not only different temperatures based off the time of year, but you also have different water temperatures based off the time of day. And that promotes differences in land-sea breeze circulation. When you have differences in the temperatures between, the land and water, right? If it's a positive or negative difference, it is the main drive of which direction the sea breeze is going to go. And when you have these changes like this, you guessed it, there's more instability, there's more possibilities for changes in the atmosphere to occur and maybe storms to form. So there's lots of things going on. And then also the jet stream positioning. Because Washington State is so far up north, it's just going to really be hit with a lot of rain. And when the jet stream hits these areas, it's going to drive all that moisture from the Pacific Ocean, and it's going to hit the Washington coastline so hard because it's the first land that's there, and the mountains are going to keep the moisture in an ongoing cycle, and it's going to prevent it from going, more inland a lot of the time. And also, it's just the proximity of the mountains to the coast. It really enhances the rain shadow effects. If you look at other areas, the big California, Sierra Mountains, or not Sierra Nevada, what am I saying? But the big mountains in California, they're really far away from the coast. There's other areas where there's mountains, but they're really not as high. Mount Olympic is a really, really tall mountain. I think it's one of the tallest in the state. For that to just be so close to the coastline really enhances and catalyzes that effect. And many of these effects are very minor by themselves, but when you put all of them together, they really make profound changes. And that is why areas like Washington State and the coastline, on the western coastline, are just ever so slightly different from Oregon, which is ever so slightly different from California, because you just have these monumental changes that compound over time, and then you get really different climates. That's how climates form, just really small changes, and they provide the ability for drastically different landscapes to form. I think that's really cool. This is a summary. I guess I could read it word for word, but I don't think it's necessary. I think the main thing to note is that a lot of these things may seem similar to areas on the western coast in general, but the fact there's just so many different dynamics going on that we really can't compare it to San Francisco directly. There's a lot of different things going on. A lot of these phenomena here, a lot of these bullet points, either exist in lower intensity or just don't exist at all in San Francisco, if you were to read all of them. And just to recap, to answer the video's question, nobody lives there because one of the biggest things is the unfavorable weather. But we have to realize, it's in the northwestern corner of the United States. That is not where we started settling. So that's why, it would have taken such a long time for American settlers to get all the way over there. And when we found places like California, why would we really go any further to some weird place in the northwestern corner where that's not really our territory, right? I don't need to get too historical, but there's just not enough of a reason to go there. And another big thing is there's a lot of reservations around the area. And that's honestly as a result of there not being people there. I feel like it's not the other way around. Yep, it's not like there's people who want to live there right now who don't get to because there's reservations there. Like, no one really wants to live there. Okay, so here's some future videos. I really want to do a tour around the United States, giving examples of all the different microclimates. I could do another one in the Southwest or just Western area of the United States, but I really want to do the Great Lakes region next. That's just something I know personally a lot about, so I'd love to make a video on that. And then we can also go into more depth about just so many different concepts in this video, but just to name a few, I want to do vorticity. I think that's something that's pretty cool, and it'll allow us to really expand our map knowledge about the weather. And so, because I'm only able to show you guys a few maps right now, because that's all I've taught you, so that'll be helpful for future videos after this one. I think that's it. Okay, that's probably like I don't know how long that was. 21 minutes. Okay, let's make this quick. Oh, I didn't even talk about some of this stuff. But these are just some maps that show the differences between ocean temperature and land temperature. You can see the ocean temperature is basically the same. That's pretty much all to it. And then here's what a vorticity map looks like. So I'm going to teach you guys what this is in the next episode. Let's skip right through that. Here's our tri-state forecast. First, we're going to start with the broader region of the U.S. As you can see, Monday we have these warmer colors over just a greater portion of the central and eastern U.S., and they've been there for the past few days, although this model doesn't show that. But once we progress Tuesday into Wednesday, we can see these lower heights, these lower colors, indicating a low pressure system that's gliding across the Central Plains and the Midwest. It doesn't really do too much after like Wednesday. It kind of fades apart, but you can see you have these little ripples and you have these curvatures in the model right here. That indicates that warmer water is being pushed into this storm. It's really not to a great degree, especially for this time of year. We really want to be more cautious with some of the more severe storms. This isn't anything too crazy, but it's going to impact weather for a lot of the U.S. And really, as this model shows, we get so much cloud coverage in the next few days. You can see that this is Tuesday. We got 1% cloud coverage. That's insane. And then almost overnight becomes 100%. Like it's crazy what weather can do, and it's going to be that way for a while, and then it's going to slowly fade out. Although I wouldn't trust the specifics. I would say it just fades apart after Thursday-ish. And this precipitation model really adds to what I've been saying. You have the storm that's going across. There is some severe weather risk, but I just don't think it's too profound. And really, the Euros tries to suggest like a little low might form over the coast, and that might provide additional showers Wednesday to overnight into Thursday. So that's something to look out for. And then as we get into the weekend, we get rapid cooling, and we almost get a frontal low moving across the southeast. But if we were to just look at the tri-state, not much precipitation to look at. It just gets cooler as the week progresses. And I think this weather channel doesn't do justice to how cool it's really going to be. I've looked at other models. They agree with what the Euro says. So that's my prediction. I think these temperatures will be a little bit cooler than what they say. So to give it a number, we'll say Sunday and Monday. I'd say both of those are going to be 14 instead of 16. And I think I'm 4 for 4 actually on the predictions. I think the last time I said it was going to be a bit warmer, and then it was warmer. And then I also said that one day it was under forecasting, certain precipitation day. And I was totally right, because that turned out to be one of the most intense precipitation days, I can't speak, of the entire spring, and probably of the entire year. Yeah, definitely of the entire year. Yeah. It was very rainy. It was horrible to be outside in. Nice to watch from the window though. So yeah, Tuesday is your best shot. Really nice temperatures. I like it a little bit cooler, so I'm kind of lying to you guys, but I think you guys will like it. That's the truth. Yeah, I mean, for me, I just love the 50s. That's like the perfect temperature for me. So I think these days will really provide that opportunity for me to just have fun in that. Okay. I think that's it, YouTube. Hope you guys enjoyed. That's like 25 minutes. Holy crap. Like, that might be the longest video I'll ever do on this channel. Nah, I'll probably do something longer at some point. But in the near future and in the moderate future, for sure. I'm going to, spend a little bit of time editing this and then post it right now. Hope you guys enjoyed the video. Please let me know what you would like to know next. And I'm out because it's 11:30 and I want to go to sleep. Peace.